like smack dab in the middle?
Because what I did was I just used this button and I took snapshots of pictures of the text and put them all into a file. And it just didn't center it out. And I'm sorry that I can't type everything. I didn't have my secretary with me yesterday.
You don't even have secretaries.
There's the point.
You could get an aide.
I don't want one.
So if people ask you, they say no. Or you say no?
Yes.
Why? They could do this for you.
I would even put in grades for you.
Why would
I don't
that's
think
kind
they're allowed
of
to
not
do
what you
that.
should be doing. Students should be seeing other students' grades. Yeah, well, I'm not like a lot of the teachers, so we probably figured that out by now. Let's walk through a few of these things just to get the idea of what things mean and how you set things up and how you can utilize the calculator to be your best friend when it comes to a quadratic style word problem. So you are making a rectangular stained glass window that is 2 foot by 4 foot. You have 7 square feet of clear glass to create a border of uniform width around the window. What should the width of the border be? First of all, what does that look like? A rectangle. So what I'm going to do is draw a rectangle. Thank you. Thank you, thank you. Please hold your applause to the end. I know the dimensions of said rectangle. 2 feet by 4 feet. I also know that I'm going to draw, or I'm going to have 7 square feet of clear glass to create a border of uniform width around the window, which means I need to put a border around the window. Sorry, it's not as clean as I wanted it. Okay, it's close enough. That border, I'm going to move this 2 and the 4 on the inside here. That border going all the way around is going to be the same width all the way around. I'm just throwing those X's in at the edges so you know that each one of those is going to represent the same value. So it's 2 inches, 2 inches, 2 inches all the way around. Okay. If any of you guys have ever had to get a poster or a picture or something framed, they will ask you if you want it matted. When it's matted, that's what it is. It's a uniform border around a picture. I had a poster, a concert poster, a couple years ago. I wanted framed and matted because it looked really, really cool. And it, really, really cool. Pearl Jam. One of the Pearl Jam shows like that too. When I went there, they what was it? Hobby Lobby or wherever I went. They wanted, well, how much of a border do you want? Like, I would like the minimal border, uniform width around so I can see all the edges, and so it just butts up against the edge lines. If you do get pictures framed, they will. This is something in the real world you will see sometimes, and then they charge you per square foot for the edges of the border. Here, you're bordering it with clear glass. So here's what you have. You have this inside dimension, and you're trying to find this area. You're trying to figure out what should that dimension be. Well, you know the area, the square footage wise, of the border. It's 7 square feet. What's the area of the actual glass frame, the glass picture you made? 8. Okay. So remember in geometry, when you guys had to find the area of the shaded region?
Yes.
You find the area of the large, subtract out the area of the small. It's kind of the same thing. Okay? So here's what we wind up doing. I know that the large area here, the dimensions would be, well, if this is 2, this is plus x plus x. So what's the new width going across?
2 plus 2x.
2 plus 2x. I know that the length would be 4 plus 2x. We okay with that?
Yes.
So the outside dimensions, the dimensions of the large item,
But how do you know it's 2?
there's one width here, one width here. See how the border is twice? It's gonna be it's the same amount on the bottom it is on the top.
Oh, okay.
It's the same amount on the sides. That's where we get the 2x's from. It's a good question. So you have 2 plus 2x, and then you have 4 plus 2x. That's the area of the whole caboodle, right? The whole thing. What's the area of the middle you gotta subtract out? 8. And what does that have to equal? Now you're dealing with just the border. How many square feet do you have to work with the border? 7. So this has to equal 7. Okay. So what we wind up with here is a FOIL combined like term set equal to 0. So if I FOIL that out, do you mind if I just move the algebra part? Oops. Just get this piece. I'll move this down so I have room to work. Are we okay if I move the picture out of the way for right now? FOIL it out. We get 7 equals 8 plus 4x plus 6x, so you get plus 10x. Hmm? Oh, 12, thank you. I added the 2 and the 4 for some reason, sorry. Yeah, 4x plus 8x is 12x plus 4x squared minus the 8. We okay with that?
Yeah.
Okay. Set the side equal to 0 and combine like terms, and I'm just going to rewrite it in descending so it looks more normal. 0, 4x squared plus 12x. The 8's cancel out, and we wind up with just minus 7. This is setting you up to a factor by grouping problem, which none of you like.
Oh,
All right. But if I told you you could find zeros on your calculator by pressing a couple of buttons, wouldn't that just be as fast? Especially if you get better at it. Let's go to our calculator. Moose is on a road trip with Grandpa. He's in Nashville on his way to Chattanooga right now.
Why did you just send your kids off?
Who is Moose?
Why?
Why? 'Cause he's in preschool. He's not like missing
What
out
are they
on
gonna
anything.
do?
My father-in-law takes his camper to the Keys in January through March. So he takes his camper to southern Tennessee or northern Georgia in October, so that way he doesn't have to pull through Illinois if it's snowy and ice and all that. So he drops it off there for a couple of months, and then he just drives down there and picks it up.
So you went to see Jeff.
So he moves on a road trip.
So like he asked you to take.
Anyway, let's go to graphs. Number 2. What I'm going to put in there is that the equation we just had was what? 4x squared plus 12x minus 7? Is that right? So we have 12x squared.
4x. No, 4x.
Thank you. 4x squared plus 12x minus 7. And then I'm just going to hit enter to get my graph.
Help me. How do I do?
Just open a new document. It's just as easy. It'll ask you. Everybody got graph on there right now? When it gets like that, just go to home and let's just do a new document. Number 1. Everybody okay then? We're getting there. So like we did yesterday, there's options on here to, not like what we did last year where it said second calculate, where it was calculate the graph. Well, in this case, it's going to be menu, analyze. All right, we're going to do the menu and analyze. What about that later? Do this stuff or do not? And when I hit the analyze value, or if I hit 6 or just scroll down to the arrow there, there's going to be an option for me to find a 0. Yesterday we worked with it, we found minimums or maximums and things like that. This is where a lot of the quadratic stuff is going to be. We're going to find maximums, minimums, zeros, all that stuff. So I'm going to hit option 1 is my 0, so I can hit enter. And it's asking for lower bound and upper bound again. That means you want to be, like we did last year with the 84s, left hand, right hand, guess, and enter. Well, here you just want to be to the left of it, so we're going to move. I'm going to go all the way over to the other side. It's so much quicker. It's nice. I'm going to be to the right of where it crosses. Hit enter. My upper bound, I'm just going to cross over. And basically, once you cross that spot, notice how it automatically came up with a 0. Sorry, Lee. One of my zeros is at negative 3.5.
Wait, so you have to do it.
Twice. Because there's 2 different zeros.
Wait, why can't you find both of them at the same time?
Because the calculator will only find them one at a time. Because it's asking you for 2 separate boundaries. The left hand and the right hand boundaries, so you have to do them separately. Find the zeros. Okay. So I do the same exact thing. So I know one of them is at negative 3.5. And then my other 0, oops, wrong one.
Is it negative 3?
I go to menu, option 6, option 1. I'm going to scroll to the right, and I heard someone already say it was at 0.5, I believe. Hit enter, and I'm just going to cross over to the other side of it, and there it is, at 0.5. So I have 2 zeros for this function. One of them is at negative 3.5. The other value for it is at 0.5. Which of those 2 values represents a value that would work in 0.5? And now is this in feet or is this in inches? It's in feet, so it's half a foot. Your border would be half a foot, 6 inches. Yes, sir?
What do you think it would be easier if you just watch this?
Wait, so you have to.
Trace doesn't give you the exact values all the time.
Oh, I was just saying.
That's why this one, when you do the calculate 0 or calculate max, calculate min, it actually is doing the value, searching for the correct value that works. Trace usually, I mean, sometimes it will be right. Trace isn't always, it's kind of an approximate.
So wait, why would it would only be the 0.5 because that was negative?
Right. That's all it is.
So what if they're both positive?
Ah, then you have to substitute and see which actually, well, they both would work, but usually with the quadratic, you get one and another. Okay. It's rare, and I see how you're thinking worst case scenario. What Cindy was saying, I don't know if you guys heard, she was saying that what happens if they're both positive? Sometimes that does happen, but a lot of times you're going to be getting values that one makes sense, the other one doesn't. So that's what you're going to look
Like
for.
if it's like a super high number.
Yeah, it might be something along those lines, because you might be restricted on domain, like you might be able to not be able to make as many widgets because you don't have so many parts or something like that. Okay. Caleb, did you have something?
No, I get it.
Oh, I thought you had something.
No, okay. Yeah, I'm listening.
Okay. Let's try another one. Yeah, half a foot, 6 inches. The border should be 6 inches.
The negative one, and then you can put it.
Well, can I have a negative border? That's why I don't use a negative border.
So you use count.
Right.
I thought you just said.
What I'm going to do here is I'm going to skip ahead to about the athletic shoe one. This is another straight quadratic one.
Wait, so are all.
These are all quadratics. All of these are going to be quadratics. Everything in this sheet here is a quadratic, or some sort of a model of a quadratic model. It's on like the 3rd or 4th page. It's number 99 on your sheet. I know there might be more than 199. I don't remember. But it's this one. It's about shoe store. A shoe store sells 200 pairs of shoes each month when it charges $60 a pair. For each $1 increase in price, about 2 fewer pairs per month are sold. how much per pair should the store charge to maximize the monthly revenue?
Are we going to do all of these?
We're gonna do a good, like I said, I'm gonna do kind of a good mixture of a lot of these things, because these are what I'm using for our notes today, and then build into it, so your homework's gonna be very similar to it, okay? So when you have one like this, you have a price and a sales figure. So you have sales, and then you have price. How many shoes do you sell a month? 200. At what price? 60. So you have two bits of information. You have sales and you have a price. And then you start to worry about, okay, for each dollar increase in price, about 2 fewer shoes are sold. So you know there's going to be a minus something here and an increase here.
So it would be
Ah, but what do you do with that? That's just going to give you a number though, won't it? Think of it this way. If I increase the price $5, I'm increasing it 5 times, right? Which means I'd be losing, well, 2 5 times, so I'd be losing 10, 2x, and 1x. For $1 increase, 1x, I lose 2 times the shoes. How many pairs, how much should the store charge to maximize revenue? Now this is what's nice with this format, is that you don't even need your calculator. How is that written up? What form is that written in? Intercept form. What occurs halfway between your intercepts? Yeah.
Well, actually, a lot of the cells are PCT, right?
Yeah. The axis of symmetry, not the asymptote. The axis of symmetry. The other A value, the other A word, right? So what we do here when we have something like this, well, get your zeros. Set 200 minus 2x equal to 0. Well, you get 200 equals 2x. What's your 0? 100. Set that one equal to 0. What's your 0?
60.
Negative 60.
I'm trying to follow to the middle.
What's 100 plus negative 60? 40. What's half of that? 20. So the midpoint would be at 20. That would be the value of x that gives me either my maximum or my minimum. Now think about what this problem would be, what it would look like if you FOILed it out. If you FOILed this thing out, you'd get something something minus x squared, or minus 2x squared. Do you agree? So would this be up like a cup or down like a frown? It's going to be down like a frown, which means you're going to have a 0 here, a 0 there, some maximum value here when x is equal to 20. So when x is equal to 20, you're going to sell the most at the best price. What's the price you're going to sell that at?
Would you just put 20 first?
Yep, that's it. So what do you charge to maximize your revenue? My maximum value is going to occur when x is 20. So if x is 20, I substitute in for just the price part. What's 60 plus 20? 80 bucks. If I sell the shoes for 80 bucks, I will make the most money. How much money will I make? Well, what's 2 times 20? 40. What's 200 minus 40?
160.
160. I will sell 160 shoes at 80 bucks a piece, so how much money do I make?
Is that
Multiply them together. That's all you have to do is multiply them together. That might be the only thing that you can't figure it out. Yes? Why 20? 20, you're okay with zeros, right? Whenever you have zeros, what happens halfway between the zeros is always the axis of symmetry. The axis of symmetry is always the x coordinate.
Okay, I got it. Yep, okay, it's fine.
Okay.
Wait, multiply what to?
The 80 and the
Because
80.
I was confused, because he said like 40, but there's 180 or 160 between them, but half of that is 80, and negative 60 plus 20 is minus 80.
Yeah. And that's the whole idea when you start piecing together what actually works with the quadratic, of knowing that you got that axis of symmetry halfway. It's either going to be your maximum or your minimum, just knowing what it looks like.
So how did you get?
How did I get 80 again? All right, remember, the 20 is the x coordinate of the vertex. The vertex in this quadratic is the maximum. So when x is 20, I'm at my maximum value. Well, if x is 20, I just substituted that in for x for my price, so 60 plus 20 is 80. I make the most money if I charge 80 bucks a shoe. Well, per pair, I should say.
Wait, so why do you only do it
Because it was asking two separate
for the
questions.
price?
It was asking two questions. It was how much per pair should they charge, and what's the maximum revenue? What they're doing here is, if you think about it in terms of the graph in x's and y's, your x coordinates are units, like the multiplier.
So what's that 160?
The 160 is how many of them I'm selling. I'm
So
selling
like
160.
60 pairs.
Yeah, I'm selling 160 pairs at 80 bucks a piece. To get the revenue, it's, the value of x is what you substitute into both of them. Remember, x isn't just $20. It's 1 times the 20. This is $1 increase. So if I increase it 20 times, I'm increasing it 20 bucks. If I decrease this 20 times, I'm decreasing it by 40. That's what that meant. That's how the interpretation of the values of x run for those. Yes. A decrease. Remember when we read it, it said it was decreased by 2? That's where it came from. Decreases are negative.
Yeah, I know that. What's that mean? Where's it from?
Oh, I thought you were just talking about 2x. I'm sorry. What I was saying here is if I FOILed this whole thing out, I'd get some value, minus 2x squared. All I was saying is that this just means if this got FOILed out, I'd have my a value would be a -2, which meant it would be down like a frown. That's why I was just showing this why it was doing this.
Oh, okay.
That's all. Okay?
Wait, so, okay, let me just do this.
Oh.
How did you pick 20 pairs?
It's the midpoint. It's always the midpoint of the
Yeah,
zeros.
like,
What's negative 60 plus 100? It's 40. What's half of that? 20. That's all,
oh.
that's all it is. That's all it is, guys. This is all it is. All right? I think I got another one. I think the one right below that is the same deal. Look at 100, the electronics one.
Hey, Mr. Murphy.
Yo,
Honestly, if you, I think, I'm not sure if it's easier, but I think if you would just have to you just throw those two numbers out, and then, I'm going backwards. I thought,
you can do that. You can FOIL it all out, but it's much easier if you understand that once you put it in intercept form, it's quicker.
Right, yeah, and then because like it's 160 times 8 equals 128. 12,000.
Yeah, whatever it works out to be.
That's the same.
So let's look at the other one that's very similar to that. You are running a home electronics store and you're repricing new models of digital cameras.
Oh.
At the current price of $680, the store sells about 70 cameras each month. Sale data from other stores indicate for each $20 decrease in price, about 5 more cameras per month will be sold. How much should the manager charge for cameras to maximize monthly revenue? What is the maximum revenue? So you have sales and you have price. The sales, when I'm talking about sales, is like how many units are you selling a month? Well, you're selling 70. Okay. You're selling them for $680 a piece.
Yeah.
The next part says that for each $20 decrease in price, 5 more are sold. So what do I put with the sales?
Plus 5.
Plus 5x, good. And then the other one would be minus 20. Good.
Well, would it be X again?
Yep. Because per $20 decrease, you get 5 more increase. If I decreased 3 times, I'd be selling it for $60 less, and I would sell 15 more cameras. That's the correlation of the value of X. That's what X is allowing you to do by the multiple there. Again, if you FOILed this out, you'd get negative 100x squared, which means it's going to be down like a frown. So I'm going to have a maximum value here. This is setting you up again to be a real fast via intercepts. If you set them equal to 0, you take 70 divided by negative 5, you get negative 15, I think? Okay. So I have 1 0 at negative 15. The other one is at 34?
No, it's more
14.
14.
Yeah, thank goodness, because that would be a halvesy and it would be really weird.
Yeah.
And the other one's 34
34.
though. Okay.
Alright, so I can do those again.
Set them equal to 0. Just find the zeros.
Oh, yeah.
Okay. What's negative 14 plus 34?
20.
What's half of that?
Yes.
So your midpoint is when x is equal to 10. So I know it's going to go up. My maximum is going to occur when x is 10. So if I decrease it 10 times, I'm decreasing it then by $200, which means how much am I selling each camera for? 480. So my X value, remember, is going to generate the most amount of sales, the most amount of revenue. So my sales price, 680 minus 20 times 10. I'd be selling it for $480. If I sell them for $480, how many units am I selling? Well, I'm going to sell 70 plus 5 times 10. I'm selling how many of them?
120.
120 of them.
Wait, Mr. Wouldn't it be negative?
What's negative?
Like when you said negative 20, X equals 680.
I'm not setting it equal to 680. I've set 680 minus 2x equal to 0. Add 2x divided by 2.
Right, you know, okay. Yeah,
So that gives me my what I'm selling it for and how many I'm selling. So what I do with those 2 numbers to figure out how much money I'm making. That's it. Okay. And I know you guys did these last year. You should have. I'm selling 120 of them a month at $480 each, which means my total revenue, multiply the 2 together. That's a lot of cameras.
Yeah.
And that's what you're looking at. All right.
Okay, once you get that 10, can you plug that into the foil and then get your answer from
Yeah, basically you can do that because it's going to still give you the total revenue. Let's see here. What I want you guys to try, aside from the other ones that I want you to look at here, on this sheet tonight, let's do this. And we'll keep working off these word problems from. We use these as the beginner ones. So let's do the Big Bertha Cannon one. 90 the shot put, the firefighter one.
We're doing these homework.
Yeah, they shouldn't be bad.
Okay, so the shot put one is the sports.
Yeah, these are just going to the next one. Yes, it's just the next one here. So this is the Canon, Bertha. Oh, that was Bertha's.
That was Bertha.
90 was the shot put. 91 is the fire.
91. Yeah. So we have to do 77 through 84 and
Then 78, again, flip over a couple pages, is about an airplane.
Did you know how to spell it?
What do you see shop for?
Yeah, it's actually good.
Oh. Explain the aviation thing.
Read it.
Yes, is aviation being?
No.
There's one about an airplane.
No,
Yes, it does.
no.
79 talks about a phone bill.
Why didn't you throw like a cannon and like a fire and like a chopper?
And 80, 80's gonna be awesome.
Volcano.
80's a volcano. I do myself so well.
Okay, so these plus.
No, just these tonight, because I want to keep working off this for tomorrow. Okay, so I gave you 6 of them. When you get these weird ones, as you read them, start to think about what does it mean in terms of what the graph might look like, and then how can you use the calculator to work itself through. Every single one of those should be able to solve via the calculator by a couple of buttons, believe it or not. All right.
All right.